Okay, so we're gonna use today SysTick, but with interrupt feature. So just like GPIO, we learn it first how to deal with them, and how to do polling, checking some bit if it's 1 or 0. Then we learn it the GPIO stuff for each GPIO interrupt, okay, and how to use interrupts with GPIO boards. Today we're gonna learn, how to use how to trigger a I'm sorry, not a GPIO, how to trigger a SysTick interrupt, okay, from that module. So basically, this interrupt is really simple. This is a timer. You load a timer with maximum value. The timer will start counting down from this value to 0, and when it reaches 0, this will trigger interrupt. But of course, you should handle this interrupt. I mean, you must write interrupt service routine and make some configuration also so that this interrupt will actually cause the interrupt service routine to execute. Okay, so it's simple. It's not hard. Also, we're gonna learn how to use how to use yeah the driver lib functions to make the programming with SysTick easier. Okay, so as you see here in the program in front of you, okay, please, if you are coding right now, stop coding. Let me explain first what's inside, then I will have time to code. Okay. So basically, this program will blink the lid, blinking, each 1 second, half a second, whatever, based on SysTick interrupt, not like the our previous approach. Okay. So basically, as I said, there is interrupt functionality in the SysTick hardware, SysTick module timer, and the interrupt will trigger when the count reaches 0. Okay, so when you reach 0, if you coded an interrupt service routine like this one here, then this code will be executed whenever we reach 0. Okay, good. So let's see what we have here. Oh, I'm sorry, this is an old one. I'm changing it here. Not forget to do that. Yeah. Okay, so good. And here we have no. Sorry guys, I just updated one file and forget to update the other file. And finally this. Okay. Now I think it's ready. Yeah. Okay. So what we have here. First, we have the function for the initialization. I will explain this at last. This line here, because this keyword is new for us, volatile. So here is the initialization. We will not do the other stuff of initialization. Okay. We have here a simple approach. Just write this here, map SysTick enable module. That's it. Then this will do, the other stuff, the 16-bit, 101 that we talked yesterday. Just one simple line like this. Okay, and just don't don't pay attention to this. Okay, so now laid one initialization. This is also something not new for you. But what is this exactly? Volatile So this is a variable initialize, a variable declaration, but with a new keyword called volatile. Okay. So basically, if you wanna make, but we don't need it here actually. But anyways, if you wanna create interrupt service routine, okay, and you want to use some variable here in this interrupt service and keep its value, you should define it using this word volatile. Okay, we will not use it here. We will use it in the second program in this lecture. But just to know that if we want to use a variable inside the interrupt service routine, GPIO, SysTick, timer, any other timer, any other module, then you have to declare it as volatile if you want to keep a certain value in it, for example. Okay. Okay, so in our main program, we're gonna first initialize lead one. Also, we're gonna initialize SysTick. So this is initializing SysTick. Okay. Then we're gonna put a duration. For example, if you wanna blink the lid each 1 second, then you put in the duration here 3 million if the clock is 3 megahertz. And I explained this yesterday. If you have a problem with that, let me know. I can explain it again. Okay. And with this very simple, line of code, instead of configuring some register and stuff, and make a big function just to do that, which is this function in here. Let me show it very quick. This function, this one. Just with one line of code, we can replace all such lines of codes, which is this line here. Okay. And again, we have the steps to configure or enable the interrupt from SysTick. Again, if you remember, guys, if you recall in our lecture about interrupts, we have something called critical section. Okay. And when you start configuring interrupts, we are starting a critical section. So in this critical section, we disable first, map disable master, not enable. Disable master. Then we enable the interrupt of SysTick. Then we enable master again. We enable again all the clocks or the interrupts. Okay. Then we go to a while loop in which we have watch for interrupt, which this function will put our microcontroller into sleep, and it only wake up when the interrupt triggers, SysTick interrupt in that case. And in the interrupt service routine, it must be called or named with this value or this name. How we could know this? If we recall in this function, or if we look here at SysTick, should be So if you want to make interrupt service routine, you should name it with this name. Okay. And in this interrupt service routine, we have only one line of code, which is toggling bin 1.0. So it will toggle, the lid every 1 second. 3 million count with 3 megahertz means 1 second. If you want to have a second, you do 1.5 million. If you want, for example, quarter of a second, you put 750,000 counts, and so on. Okay. So if we compile this guy and run it on our microcontroller. Okay. So I'm gonna show you the. So it's blinking each 1 second. Okay. I hope you can see it. No, you can't, right? Yeah, you can see it now. And if we look at the oscilloscope, okay, it's a square wave. And again, we have the time is, I'm not sure if you can see, but anyways, the time is 500 milliseconds. And we have two squares, two divisions. So this is 1 second, 1 second high, 1 second low. Okay. Okay, guys. So please code this very quick. Then we're gonna take another, another application for SysTick. Okay. Any questions? You're okay with this?
I'm not sure if you can explain duration again.
Yeah.
And how map.
Yeah, that's fine. Okay.
That period.
Are you checking it, Professor?
Let me. Thank you. Let me check. Let me answer the question of Johnny first. Then I will get back to you, Clark. Okay. So yeah, we have been here.
I didn't really fully understand the duration or the how it worked exactly.
Okay. Okay. So basically, SysTick is working as follows. You load it with you load some registers there called val register, I think. Not val. Anyone remembers what this?
Wasn't it load?
Load. Yeah. Thank you. Load register. Yeah. Thank you. You load this register with some value n. N should be less than or equal to this number. Okay, because this is the maximum count you can have.
Right.
Then what's gonna happen is that the counter will start counting down n minus 1, n minus 2 until it reaches 3, 2, 1, 0. Then it will go back to n and continue. Okay, right. Overflow. Now, I want, for example, I know that it count based on some count, but I want to relate this to some time. If I want to make a delay, for example, 1 second or half a second, what I should do? What value I should load to this load register? What will be the n? Okay, so that's the question now. For example, we need to know for this the clock frequency. So let's assume the clock frequency equal to 3 megahertz. And we want a delay of quarter of a second. And the required delay equal to 0.25 seconds. What should be n? Okay. We know that the counts, the time between a count and the next count is t clock. So the time between here and here is t clock, between here and there, t clock, and so on. So one count, t clock. One count takes a time equal to t clock. What is t clock? It's 1 over f clock. In that case, it's 1 over 3 megahertz. So how many counts to produce 25 seconds? This is, of course, a second. It's time. Then you do the, crossover. I don't know what they call it here, but anyways. So n multiplied by 1/3 mega equal to 25 multiplied by 1. So basically n equal to 0.25 multiplied by 3, 6. This is 750,000. Okay, count. So you load, if you load the load register with this number, this will produce a delay equal to 0.25 seconds.
Oh,
This is clear now?
yeah, it's clear.
Thank you. Okay, so give me 1 second, Clark. I will set up. So I will continue now. Okay, and you guys, just 5 minutes. Then you go back and if you want to continue the first one or do the second. Okay. So let me share my screen again. Okay, so let me just close all these guys. Yeah. Here is another application. Okay, if you remember, guys, we took SysTick, we created delay, then we created PWM signals. Okay, and that's what we're gonna do now. Okay, but we will do the PWM using interrupts. Okay, so look at the this this program, because it's not that straightforward as you might think. Okay, we will take some other timers in the future, maybe I think next week. Okay, in which you can directly implement PWM signals better than this SysTick. Okay, so
Professor,
yes.
you have enable master twice for map
Yeah,
interrupt.
again, yeah, I don't know. I think I think it's actually not working for some reason, because it's not working. Or yeah, I'm sorry. It's working, it's working, but since our critical section is not that critical, so it will not show no benefit, but it's it's not correct and incorrect coding. It's a safer coding, we can say. I like to do that in that way, especially when you configure interrupt. Although I am sure that if I just comment these 2 lines, nothing will happen. Okay. Okay, so again, these 2 parts are exactly like the one we saw in the first, first program, first code. Okay, what's extra here is that line of code in which I am defining or declaring a new variable, but I'm adding this volatile keyword, and I will show you just after 1 minute why I'm using this one. Okay, here I am giving this variable a value which is 3 million, means 1 second. Okay, and I set the period of SysTick using this value, which is 3 million. So basically it will give you in the beginning a delay of 1 second. So it will count from 3 million to 1, and this is 1 second. This is equivalent to 1 second delay. Good. Then I am disabling master, enable master, and in between I enable the interrupt of SysTick itself. Okay, and why I'm putting these 2 lines of code is just a kind of safe coding. Although you can just ignore them, nothing will happen. Okay, but since usually setup of interrupts, you don't want this part to be interrupted by other interrupts that you don't know about, or you are not expecting, then it's safer to use this disable master, enable master before and after your critical section, the sections that you don't want to be interrupted while executing. And here is our while loop, infinite while loop, and here wait for interrupt. Now in the interrupt service handler, what I want to do exactly is follows. I want to turn on the LED for 1 second and turn off the LED for How much is this? 3 seconds. So 1 second on, 3 seconds off. Or the duty cycle is 25%. High is 1 second, low is 3 seconds. Okay, good. So in here, I am checking the duration, this variable. I am checking its value. If it's 3 million, then basically I will turn on the LED, set high, on output bin 1.0. Then I will change the duration and make it 9 million. Okay, and send the new period to SysTick. So now I am configuring SysTick to start counting from 9 million, not from 3 million. So the delay will be 3 seconds, 3 times the previous one. Okay. Then yeah, since it's if else, so you either duration is 3 million or 9 million. If it was 9 million, okay, I will put low. Then I will set up the duration to be 3 million and send the new duration or configure the new duration to SysTick module. So the duration will be 3 million now. Okay.
Hey,
So
Professor.
whenever the count finished reaches 0, this the interrupt service, the interrupt SysTick interrupt will be triggered, and when it's triggered, this function will be called. Based on the previous value of the duration variable, okay, either 3 million or 9 million, one of these will be, one of them only will be executed. If it was 9 million, I will put the duration to 9 million and turn on the LED. If it was 9 million, I will turn off the LED and set the new duration to 3 million. Okay. So any question on that?
Hey, Professor. So that SysTick
Good.
handler,
So let me execute it. Oh, sorry, compile it.
Professor, can you hear us?
Then, yeah, just before this, after this, yeah, that's fine. So why now I am using this? Let me go back. Let me go back very quick. Why now I'm using this volatile? If you see here, I am using duration inside the interrupt service routine. Okay, and I want anyone have a chat or something? Yes, Genesis.
hey, Professor, can you hear me?
I don't think he can hear us.
Oh, okay.
Professor? Testing. Hello? Nope.
What we should do?
Might be the Zoom option that's causing the problem.
Can somebody speak to me to check this one?
Hello.
Hello, Professor. Can you hear us?
Yeah.
Can you hear us?
Okay.
All right.
Testing.
Yes.
Testing.
Okay, so we have here a question from Genesis.
Oh yeah.
Yeah, SysTick
Yeah, it
here
was-
will generate PWM signal.
Okay, okay, got
Okay.
you. All right, thanks, Professor.
Okay, so let me now. I forgot again to explain why non-volatile is important. Okay, so why volatile? Okay, I'm here using duration inside the interrupt service routine. Okay, if it's just a global variable, the compiler may you know delete the variable, okay, after getting out of this SysTick handler. For that reason, to keep its value, 3 million, then for example 9 million, and so on, you use this volatile keyword. This volatile keyword means this variable might be used in the interrupt service routine. So please, compiler, don't omit this variable. Don't refresh it or don't
So is that kind of like a global
overwrite it
variable?
somehow. Yeah. It's a global variable, but a special case, it will be used inside here.
Professor.
Okay.
Okay.
I just want to ask, what's the benefit of using interrupts instead of just putting a timer and setting high to low or toggling a certain lead? It seems a bit too, I would say, like advanced to use an interrupt handler just for a single lead light.
No, this is not just. This is just a simple example for it. Okay.
Okay.
That's it.
I'm just wondering, like if we are building a robot, would we just then use a timer instead of using interrupts for LEDs?
You can use whatever easy for you. So you should, when you learn something, you learn all the options. Okay. Then, based on your application, you might find, many of the things that you learned, has no value with what you are really doing right now. But that does not mean that they are not, of no value at all. Okay, so I'm giving you all the options, all the features. Okay, and for some applications you might use some, for other applications you might use others. That's it. Okay,
Okay.
but when I give examples, I usually use lead one because it's easy to see, easy to debug. You know, that's
No, I'm
the
just asking, like, what's the benefit of using an interrupt handler specifically instead of a timer or just like a case statement, like a switch or if.
you can do. Using interrupt all the time enables you to do something else. So here in the while loop, you might use, you might do is any other things. Okay, whatever it is. And while this is executed, okay, then whenever the interrupt, triggers, it will go here, do some stuff, and go back to the while loop. So it's a kind of multi-threaded. So it's like if you have many threads, okay, one of them is you are currently doing, and the other will be triggered by the hardware. That's the benefit of using interrupts. You may
Okay.
use it, you may find, if you really want, okay, then you have this too. Okay.
Gotcha. Thank you.
Okay, so let me now do it again. Okay, I don't know how much it is. I think it's the beginning, it's 3 million. So this part will be executed. If we go, yeah, and then it will change. And next time, after 1 second, now it's 9 million. So we set low, we turn off the lid, and we just continue. See, change the game and so on. Next time it will be 3 million. And so on. Next time 9 million. Okay. Now let's disable the breakpoint and look at the so here is output, 3 seconds off, 1 second on, 3 seconds off, 1 second on. And here is, it's obvious, you know, the duty cycle is 25%. Okay. Okay, guys, take your time. Okay. And whenever you finish,